Okay, so we are going to discuss about comparing distributions. Distribution. So again, we have discussed a while ago about bar chart, but let me just add additional discussion for that. Bar charts are often excellent for illustrating differences between two distributions. Now, it can be defined as a chart or graphical representation of data, quantities or numbers using bars or strips. Take note, here on the definition, you would notice the word two distributions. Because in a bar chart, there is also what we call the y and the x-axis. Now, when we try to create a bar chart, and that is what we mean by the two distributions. Now, here is an example of a horizontal bar chart. You would see on the x-axis, you have the kind of cards being played. You have the spade, you have the euchre, pinochle, canasta, hearts, cribbage, gin, bridge, blackjack, and poker. So these are the games played using cards. So that is the y-axis, and you have the x-axis, wherein the blue color tells us that the day it was played is on a Wednesday. And then you have the colored yellow, which tells us that it is played on a Sunday. Now, just looking into the bar chart, no, you would notice that most of the players are playing the cards for spades on a Wednesday. More number of playing cards is on a Wednesday using spades. Same goes with the euchre playing game cards, which has, you would see that it has also an increased number of how many times it was played on a Wednesday. So this is a kind of graph that shows us comparison of playing cards on 2 days, that is on a Wednesday and on a Sunday. In this case, we are comparing the distribution of responses between the surveys or condition. The condition here are the days. Figure 3 shows the number of people playing card games at the Yahoo website on a Sunday and on a Wednesday in the spring of 2001. So I hope that is clear. Now, there are some graphical mistakes to avoid. So instead of plain bars, it is tempting to substitute meaningful images. No, that is a mistake. Now, if you use images instead of the bar, so let us try to see that. No, so here you would see people sometimes add features to graphs that don't help to convey their information. For example, a three-dimensional bar graph, such as the one shown in Figure 4, are usually not as effective as their two-dimensional counterparts. Why do you say that it is a three-dimensional? Because you can see the top view, the front view, and the side view of the graph. And does it help on the interpretation? No, so this is a way of trying to put an aesthetic on the chart. Nonetheless, it does not add any meaning to the chart. Okay, so here another example, a mistake in doing a chart is trying to put images. So in Figure 5 presents the IMAC data using pictures of computers. The height of the pictures accurately represent the number of buyers. Yet Figure 5 is misleading or confusing because the viewer's attention will be captured by areas. Because you would see that on the Macintosh, which has a large ownership in terms of iMac, it's a big image. Sometimes it will confuse the viewers or the one who would try to interpret the data. So this is one mistake. Now, Edward Tofty coined the term life factor to refer to the ratio of the size of the effect shown in a graph to the size of the effect shown in the data. So on the presentation a while ago using computers, you see that there is a large image which create an effect on how you are going to interpret the data. He suggests that life factors greater than 1.05 or less than 0.95 produce unacceptable distortion. This only means that bigger images will create distortion or confusing interpretation of data. Okay, so here a bar chart. Another distortion in bar charts results from setting the baseline to a value other than 0. Usually when we try to count, let's say for example the number of buyers, usually you start from 0 to 50, 51 to 100, diba? Or 51 to 120, 121 to 190. Here you would see that the number of buyers on the y-axis does not start from 0. This also create distortion or confusion doon sa mag-i-interpret, those who will interpret your graph. So now the baseline is the bottom of the y-axis, representing the least number of cases that could have occurred in a category. Normally, but not always, this number should be 0. But on the graph presented a while ago, there is no 0 on the y-axis, and it will create confusion in doing a graph. So line graph, we note that it is serious mistake. It's a serious mistake to use a line graph when the x-axis, the horizontal line at the bottom, contains merely qualitative variables. So you would see here, you have here the kind of game which is considered a qualitative variable, or the categories are put at the x-axis, like blackjack, bridge, etc. The kind of games that they play. This is a big mistake, in doing a line graph. It should be something like number should also be put on the x-axis and not the name of the game, which is somewhat it's like a qualitative variable. A line graph is essentially a bar graph with the tops of the bars represented by points joined by lines. The rest of the bar is suppressed. So it's basically much appropriate to just use the bar, because you can, instead of the line graph. So this is the point that is being emphasized in this statement. You also have here a scatter plot. If you have two variables that pair well together, plotting them on a scatter diagram is a great way to view the relationship and see if it is a positive or negative correlation. But here, when you try to see the relationship, you must create on your mind a line. A line going from, you would see here on the graph, 0.9 going upward to the right, to the right. That means it is positive in relationship. So you would create on your mind a line going up there, and you would see how many dots are close to that line. It will tell us how positive are the relationship of variables. So if you create a line over here which tells us the positive relationship, so you would see that there are many variables which are away from the line, yan, ganyan. But if you have a line starting from 1.5 going on the left direction upward, that would mean that the relationship is negative. Now this kind of scatter plot though can tell us relationship of variables, or relationship of the variables, or the data or the participants' relationship in terms of the variables. Here you have the flash recovery time, seconds, and volts after flash. And then the relationship observed can either be positive or negative, or nonlinear or linear, and or strong or weak. So if you create on your mind a line going upward direction to the right, that would mean that relationship, the points closer to that line, meaning there is a positive relationship. But if the points are away from that line, meaning there could be no relationship on that, so yung ganon. Okay, so another graph is the histogram. The histogram is a popular graphing tool. It is used to summarize discrete or continuous data that are measured on an interval scale. So what are the samples of discrete data? So let us say, for example, how many during the flood in some areas in the Philippines, where there are deaths, how many people died on that particular disaster. So ito, you have to count how many, no? So that is an example of a discrete data, no? And you can plot that, no, using a histogram. So let us say here, one example is the number of employees, and you have the salary. No, so you would see that the number of employees ranges from 0 to 600. No, and you have the salary in thousand, no, in thousand. So you have here from the x-axis you have 0 to 10, which means that 0 to 10,000, no, US dollars. Okay, 0 to 10,000 US dollars. So you have 50 employees, no, who have a salary of 0 to 10,000 US dollars. And the second bar, no, would tell us that employees, 300 employees had a salary that ranges from 10 to 20, no, US dollars. So this is an example of bar graph. No, it is often used to illustrate the major features of the distribution of the data in a convenient form. So additional tips, the graph should always add important information rather than repeat information that already appears in the text or in a table. So usually when you that's the main problem, no, or the flaws, no, in writing interpretations for data. You do not repeat or describe anymore what you see on the graph. You just put on the meaning, no, when you try to write it, because that's a mistake, no, that we can do, that you try to describe although there is a table already being shown. No, it's just doing a redundant description of the data. So it should be as simple as possible, and graphs should be interpretable on their own. No, so yan. As a summary, pie charts and bar charts can both be effective methods of portraying qualitative data. Because what is a qualitative data? So meaning, let us say for example, the kind of games being played, no, that is a kind of qualitative data. However, what makes it quantitative is the number of person who plays that card. No, so bar charts are better when there are more than just a few categories and for comparing two or more distributions. No, be careful to avoid creating misleading graphs. So that is all, no, for PowerPoint number 2. So I hope that is clear.